Hi everybody, it's John Pushkar, and I'm usually here telling you about how to stay safe in the world of fuels and fired equipment. But today I'm taking a little segue, and today I'm trying to address some issues that are headlines in the news. And I'm sure that you've heard plenty in the last week or so about how the U.S. plans to step in and help Europe with natural gas supplies. And you keep hearing that it's going to be LNG to the rescue. And although LNG is going to be an important piece of helping Europe, I wanted to take a few moments and educate you about the basics of LNG. And I wanted to introduce you to one of the best articles I've been able to find. This is a VOA, Voice of America article. And it talks about the fact that U.S. aid will help Europe replace Russian LNG, but not pipeline gas. This headline reflects how I feel about this and what you need to know. Although we can help Europe with sending them LNG, we cannot step in and immediately help their entire natural gas situation. So LNG means liquefied natural gas. And after you learn a little bit about the basics, you'll understand that all we're going to do is displace some Russian LNG. We're not necessarily going to have the storage or vaporization capabilities to really back out a bunch of their pipeline gas. That takes a long time, and you're going to understand that very well in the next 10 minutes. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. So I want to talk to you a little bit today about what LNG is, how it's made, how it's stored. I want to talk about how it's used, and I want to talk about some LNG hazards. And this will, I think, complete an overall picture for you about what we're hoping to do or what we can accomplish with LNG in helping Europe. LNG was originally developed as a means to help balance pipeline supplies. So quite some time ago, when there was a limited number of wells, wells produce at some rate, and it's usually a declining rate from when they're first discovered and put into service. That's why you always have to have new wells coming online. But if you think about it, most of natural gas usage, at least here in the United States, it's a seasonal type of thing. A lot of it's used for space heat. So you got this big seasonal imbalance. Well, how do you deal with that? Well, in some places there are caverns to be able to store gas. They store it under pressure. But in other places where there's no other storage available, the technology has been developed to first liquefy it, which means you get it very, very cold and it changes phase, just like steam comes out of liquid water. Well, natural gas comes out of liquid natural gas, or vice versa. You condense steam into water. Well, you can condense, in essence, natural gas. The first evolution of this was to create liquid natural gas and to use it to supplement pipeline capacity. And then it was in later years, kind of recently, that it's been able to be exported. There is a safety standard, by the way, if you're interested in some of the details of how this is done safely, requirements for constructing facilities and operating them. Well, they're in NFPA 59A. I'm a recent member of the NFPA 59A committee. You've got to remember that LNG, well, it's liquefied natural gas, but the commercial term natural gas means that something is typically 95% methane and 5% other things, some other hydrocarbons, maybe some inerts, but LNG is 100% methane. So it's created and stored as a liquid at minus 268 degrees Fahrenheit. When you first take natural gas, you've got to then take it to a facility, an LNG plant, where you've got to remove all of those other things so that you just have pure methane, because they don't behave the same when you try to get them very, very cold. They condense at different temperatures and they have different properties and characteristics that are not desirable if they stay in the mix. So you get it very, very cold, suddenly it condenses, it turns into a liquid, and it's a 600 to 1 volume reduction. Then in very specially designed structures, tanks that have special chemical compositions of the steel, and that was learned the hard way, and I'll show you that in a few slides. You can store this, you can truck it around, you can send it on ships, on rail cars, and you could take it to a site that has vaporization equipment. You then have to vaporize it so you get substantial quantities of the gas available. Then you can inject that into a pipeline. Few more details I'm going to go over about that. So throughout the United States, throughout Europe, there are interstate pipelines. There may be, 1,000, 1,500 pounds pressure. Local distribution companies like your local gas supplier might take off of this pipeline. They reduce it in pressure, and they may or may not have a liquefaction plant. That's where you're actually condensing or turning this gas into a liquid. So one of the struggles with providing LNG to Europe is that we have to likely have more liquefaction plants created here in the United States. It's very specialized equipment. There are compressors involved to create the refrigeration cycle needed to get very cold temperatures. It's very long lead time. It's very complex. You have to have permitting and siting for the locations of these facilities. You have to have storage tanks on site to store what you've liquefied. And it's all a very highly regulated, highly complex, very intricate process. You just don't decide to create one of these and throw it up in a few months. They're typically years in planning and construction. Like I said, these tanks, they're typically double-walled, insulated. They're specially constructed with a lot of things considered in the planning. There's typically diking or some type of distance requirements in case there's leaks. There's been all kinds of testing and analysis of how to locate these, how to protect these kinds of tanks, what they should be created from. And typically these are very, very large tanks. And again, very specialized construction. So I'm showing you on the right-hand side here an LNG cargo vessel. You can see it's got 4 spheres. Spheres are very efficient from a design perspective to hold large quantities of liquids under pressure. You can imagine you want to send a bunch of LNG to Europe. Well, how many LNG vessels like this do we really have? You can imagine how long it would take to create vessels like this. And even when you get a vessel like this to port, unless there's a vaporization facility right there, now you need a whole network or series of specialized trucks, like I'm showing you on the left, that are actually designed to handle LNG. Okay, so let's assume I got a bunch of LNG to Europe. Now, how would they actually use this? So now I've got to vaporize this, which means I'm going to change phase from a liquid back to a gas. Then I still have a very cold gas. Now I've got to heat the gas. Now I put it into some existing pipeline system where I've got to regulate the pressure and the flow. And then I typically have to odorize it because remember, pure methane, when it comes from a well, for example, it's not odorized. Odorization is supplied for safety reasons so that if there should happen to be gas leaks, they can be discovered by, average people. It's not the preferred method of finding leaks, but it's really there as a safety device when gas is transported through populated areas. The Federal Department of Transportation has requirements for what type of odorant and how much should be installed when gas is transported through areas of different population densities. And these vaporizers, well, the one on the right, is actually an atmospheric unfired vaporizer. Remember, gas at minus 268 degrees, if it sees 50-degree ambient temperature, that's over 300 degrees of temperature differential to drive the vaporization. The problem is that you need lots and lots of surface area. So unfired vaporizers have somewhat limited capacity. And this is from a project that we did for a client at a mining site. It's a relatively small capacity system. Most commercial utilities that vaporize on a large scale, they're fired vaporizers. So like the one I'm showing you on the left, that's a submerged combustion fired vaporizer. We're firing burners into large pools of water. There's special stainless steel piping with the LNG in it that's immersed in these baths of water. And we slowly, gently transfer heat from the water into those coils, and it, again, vaporizes, boils, if you will, that very, very cold liquid, turns it back into a gas. But you may have many, many, many burners and large quantities of these water baths to actually vaporize lots and lots of LNG at the same time. So again, I'm showing you this because I'm trying to get the idea in your head. This is complex equipment that is very expensive, very hard to get, has to be very carefully installed and commissioned, lots of safety devices. I'm trying to get you to understand that this also can't happen overnight. This takes months, if not years, to put into practice. And once you vaporize the gas, you've simply changed phase. The gas is still very, very cold. You can't send minus 268 degree natural gas that's now in a gas form into piping systems. If you do, you see what happened on the left there in some of these other pictures. It forms ice structures on the outside of the piping, and then fuel train components don't work properly. Now, these icing pictures also happen when you reduce pressures dramatically in conventional systems. So most facilities have gas pipeline heaters. This is another whole set of equipment that needs to be purchased, carefully designed and installed when you have LNG systems. This is an electrical trim heater on that small atmospheric vaporizing system that I showed you that was for an industrial plant that we helped retrofit. And this is a somewhat larger fired water bath heater that's associated with larger quantities of vaporization at a site. So again, it's liquefaction equipment. It's shipping this material. It's receiving and then vaporizing this material. It's then getting it to a suitable temperature to be able to put in to an existing pipeline system without causing damage. So what about some LNG hazards? Is LNG inherently dangerous? The technology to create, transport, and use LNG safely is well developed today, but it wasn't always that way. In fact, one of the most horrific, worst LNG disasters of all time happened just a few miles from me here. I'm coming to you from my studio here in Cleveland, Ohio. And on the other side of town, in October of 1944, was the worst LNG accident in history. The four basic LNG hazards out there are that LNG is a cryogenic liquid, just like liquid nitrogen is a cryogenic liquid. So these things, when they start to get warmed up, can expand rapidly, especially when they change phase from a liquid to a gas. Remember, this is a 600-to-1 volume reduction. So when you heat it, it expands in volume 600-to-1. And if you trap some of that liquid in between two valves in a section of pipe and you heat it, or if a pressure relieving device should fail, of course it generates a lot of pressure and that could be a problem. Also, if there are leaks, of course, or a release of LNG, it's methane, it's flammable. When there are large releases of LNG, it condenses the moisture out of the air. Methane can displace oxygen, so it's an asphyxiant. And contact with cryogenic liquids or fluids, well, they create skin burns. So again, I hope I've provided you with some insights into what LNG is, how it's created, how it's used, and I hope this helps you to better understand some of the issues that are in the news today. I hope you now understand that although we can create and send more LNG to Europe, it takes lots of infrastructure, it takes lots of time, it takes lots of planning. We're especially hampered today with supply chain issues, the cost of commodities. You should know that the technology for making LNG safe and a very effective energy solution is here today. But as I've explained to you, and as it's explained in the article, it's unfortunately not going to be able to displace all of the pipeline gas that Russia is making available. This will take some time. I hope that you've learned something valuable. Don't forget, if you haven't subscribed, please do so. It's no cost and it's anonymous. And please check out my channel. I've got another 50 episodes there of very important information that can help keep you safe in the world of fuels and fired equipment. Remember, the life that you save, it just might be yours. Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services Online School, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being a legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours.